Hello and welcome to our video about Ohm's law and the Ohm's law triangle. We will answer two questions today. First, what is Ohm's law? And second, how to use the Ohm's law triangle. If we look at the Ohm's law triangle, we can see that there are three parameters involved: voltage, current, and resistance. A simple definition of Ohm's law tells us that the current in a circuit is equal to the voltage divided by the resistance. But before we delve into how to use Ohm's law, let us first look at what each parameter is doing. In the simple circuit shown on the right, we can see that we have a voltage with the symbol V. This voltage can come from a battery, a generator, or a public supply network. In our examples, we will be using a battery as the source, and this is indicated by the two horizontal lines next to the letter V. The voltage is the pushing force or electromotive force that makes electrons flow around a circuit. If we look at the current next, we see that this parameter is measured in amps and often uses the symbol I. Please do not be alarmed by all these symbols and names. There are not that many of them, and they are soon learnt. The current is the flow of electrons around a circuit, and it is important to note that the electrons that flow out of the battery on one side must return to the battery on the other side. What goes out must come back, and this is shown by the two purple arrows, out and in. That leaves us with resistance. Now, resistance is measured in ohms, and we can use the symbol R or the Greek letter omega, and you can see this symbol in the yellow box on the circuit. This yellow box is how we represent a resistance. This might be a kettle element, a cooker ring, a resistor in a radio, or something else. Even the connecting cables will have a small amount of resistance. The resistance slows down the flow of electrons. It makes it more difficult for electrons to move around. Now that we have a basic idea of the three parameters of Ohm's law, let us look at how they affect the circuit. We will start with V for voltage, and now we have shown all three parameters on the diagram together. Voltage is going to be the force that makes the electrons flow around the circuit, and the more voltage that we have, then the more force we will have, and this will make more electrons flow. More voltage means more current. If we reduce the voltage, there is less force, and so the electron flow will reduce. And we can say more voltage, more current, less voltage, less current. If we move on to resistance or ohms, we can see that the current flows into the resistance at the top of the yellow rectangle and out at the bottom. This is how we show a simple circuit. This resistance will slow down the flow of electrons by an amount that depends on the size of resistance. It has the opposite effect to voltage. If we increase the resistance, then the amount of electrons flowing around the circuit will reduce. If, instead, we make the resistance smaller, then the electron flow will increase. Now we can say more ohms will result in less current, and less ohms will allow more current. This leaves current using the symbol I. In our simple diagram, current flows from the battery along the red wire in the direction of the purple arrow. The current or electrons then flow through the resistance and back to the battery along the blue wire in the direction of the second arrow. It is very important that you realize that the current cannot alter the other two parameters. I will say that again. The current cannot and does not alter the other two parameters. Current is the result of what happens with the voltage and resistance. If we change the voltage, we will change the current. If we change the resistance, we will change the current. We cannot do it the other way around. Voltage or resistance must change before the current changes. Okay, with the basics out of the way, we can now move on to some simple Ohm's law calculations and how to use the Ohm's law triangle. We can calculate three things from Ohm's law. The process is not complicated, and I will show you an easy way to do these calculations. We said earlier that the current was equal to the voltage divided by the resistance, and this is shown in the top formula. We can rearrange this and come up with a formula for resistance, which is the voltage divided by the current, as shown in the middle box. A final rearrangement will tell us that the voltage is equal to the current and resistance multiplied together, shown in the bottom box. Do not worry too much about remembering these formulas at this stage. There is a much easier method that I will show you right now. Instead, remember this, the picture of the Ohm's law triangle. If you can get this image firmly fixed in your mind, then you will not have any problems in performing the correct calculations. Ohm's law is one of the basic building blocks for electrical work of any kind. We show it again here against a simple circuit. All electrical circuits come down to this simple representation. Voltage pushes electrons around a circuit, and the resistance will slow the current. It will reduce the electron flow. Our first example of a calculation is shown here. We have the Ohm's law triangle in yellow, ready to help us, and we have the simple circuit ready for us to put some numbers onto it. In this example, we will be asked to calculate the current if we are given the voltage and resistance. The easy way now is to draw another triangle, a blank one in white this time, so that we can insert the numbers as they are given to us. So, we have been told the voltage is 10 volts and the resistance is 5 ohms, and this information can be put onto the diagram. Now, let us put the 10 and 5 into the triangle, and the rest is easy now. Look at the positions of the two numbers. Move the two numbers outside the triangle, and what do we have? A 10 on top of a 5. This is a division calculation. 10 divided by 5 gives us 2, and this is our answer, 2 amps. We did not need to remember any formulas, we just looked at where things were on the triangle. In the next calculation, example 2, we are asked to find the resistance of the circuit if we know what the voltage is and we know what the current is flowing. Drawing your triangles and the simple circuit again, and now we can begin to fill in what we know. If we are told that the voltage is 12 volts, we can put this against the V on the diagram. Now we are told that 3 amps of current are flowing. Put this next to the I on the diagram. Put what you know into the white triangle, which should be 12 on top and 3 on the bottom. Move the numbers out of the triangle, and hey presto, there is our calculation, 12 over 3. This will give us an answer of 4 ohms. So, if 3 amps is flowing in a 12 volt circuit, then the resistance must be 4 ohms. For example 3, we will work out the voltage. If we are given the current and resistance, we can follow the same method, but the calculation is now different. This is where the Ohm's law triangle helps us. We don't need to remember the calculation, just look at the triangle. We know that the current flowing I is 5 amps, and we also know that the circuit has a resistance of 6 ohms. Pop these onto the diagram in their correct places against the I and the omega symbols. Put the numbers into the white triangle, 5 on the left and 6 on the right. If we move these two numbers out of the triangle, we see that they are on the same line, the same level. We cannot divide them. They are not one above the other. They are next to each other. The opposite of divide is to multiply, and this is what we do. In multiplication, the numbers are written next to each other. So 5 times 6 will give us 30. If the current is 5 amps and the resistance is 6 ohms, then the voltage must be 30 volts. In the next example, example 4, we will use all the values from example 3 and make one small change to see what happens. The diagram at the top left shows the voltage is 30 volts. The resistance is 6 ohms and the resulting current is 5 amps. Now what we want to do is halve the voltage. That is the only change we have made, halving the voltage from 30 volts down to 15 volts. We can draw this on the bottom diagram. And we know that the resistance has not changed, so we can put our 6 ohms onto the diagram. The current, however, is dependent on the voltage and resistance. So although we only change the voltage ourselves, this will make a difference to the current. Let us put the values onto the circuit drawing, and we can also add our Ohm's law triangles. On the white triangle, we can now enter the numbers that we know. 15 volts on the top and 6 ohms on the bottom. Move the numbers outside the triangle and we have 15 over 6. Bingo! There is our calculation. Divide 15 by 6 and our new current is 2.5 amps. What does this mean and what does it tell us? We said that less voltage will push less current around a circuit, and now we can see by how much. In this case, we halved the voltage and the current halved. For a fixed resistance of 6 ohms at 30 volts, the current will be 5 amps, and at 15 volts, it will be 2.5 amps. We hope you've learned something from this short video. As I said earlier, Ohm's law is a fundamental building block to electrical knowledge. Get to know it. If we know any 2 parameters, then we can calculate the third. And we have also learnt that changing one parameter will mean changes to another. If you can visualize the Ohm's law triangle and the simple circuits shown, then you will always be able to quickly and accurately make the correct calculations. As with all learning, repetition is the key. Practice and practice until it becomes second nature. Once you've understood the memorized Ohm's law, you will have another powerful tool in your mental toolbox. Thank you for watching this video. We are continually adding to our video collection, which will cover a wide range of electrical subjects and topics. Please click the subscribe button and we can keep you updated as more videos are made available. You can also find us online at learnelectrics.co.uk, where you will find more tech tips and electrical help, including a section for DIY and householders and how to work and live around electricity safely. Thank you once more, and we hope to see you again very soon.